Okay, so today we'll discuss about the interest. To get an idea about the interest, there are mainly two scenarios. Either we invest in some, let's suppose a person have some sort of money and he just invested, and that is based on some interest rate. And as a result, he gets some amount after some time period that is a bit more than what he actually invested. Another scenario is the person just get loan or borrow money from somewhere on some rate of interest, and in the end he have to return a bit more than the actual amount. Okay, so mainly there are two type of interest which we consider in a GRE. One is simple interest and one is compound interest. Okay, so let's get started with the simple interest. The whole concept of simple interest revolve around one basic formula. And before getting into that formula, let's see what are the basic terminologies which we usually use in that formula. First one is the principal amount. Which we usually represent it from a P. The principal amount is the initial amount of money deposited or borrowed. This is initial amount, which is either deposited or invested. And the other scenarios, either we borrow from someone or we take loan, right? For example, if we deposit 1,500 in the bank, and other scenarios, if I lend some amount from the other person. This is first thing, the principal amount. The next thing is the rate of interest. Which is usually presented from R. Okay, so this is percent. The rate at which deposited or borrowed money earns interest each year. It is basically a rate at which the deposited or borrowed money earns interest each year. This is usually represented per annum, per year, but this could be per quarter of the year, per semi of the year, per day, per month. It depends, and we will see each of these scenarios while we move forward. This is the rate of interest. The third thing is the interest is represented from I. And interest is an extra amount usually paid on the borrowed amount or earned on the deposited amount. So two scenarios. First, this is basically extra amount, right? And the first thing is, which is usually paid on borrowed amount. Another scenario is it is earned on the deposited amount. Right? This is third thing. The fourth part is the number of years or the time period. This could be in a year, this could be in a month. If we can call this a time period. The time for which the money is deposited or money is borrowed, right? So total time period. Okay, so based on these four basic terminologies, so what is a formula for the simple interest? Simple interest and in short form, let's suppose if I call this as denoted by SI, this is principal amount into number of years or the time period into the rate of interest. And if I just represent this in a short form, let principal be P, number of years be N, and rate of interest, this could be R, the symbol of that, or this, you can also write this as P and R over 100, right? And for example, if a person invested 1,000 and $1,000, and with the 5% rate of interest, so what will be the simple interest on that amount after 1 year? So just based on this formula, the principal amount is 1,000, the number of year 1, and rate of interest is 5%. So divide by 100, so this will be 50, right? So this is simple interest, which is calculated. And remember one thing: simple interest is always calculated on the principal amount, right? Okay, so if the question asks the simple interest, this is very simple. You can simply use this formula. And the question could ask the total amount which the person has in his or her account after 1 year. So that will be, for example, if I call a total amount as A, so this will be the principal amount or the initial amount plus the simple interest, which we just calculated earlier. And so this is P, and this is P and R over 100, right? So we can also, if I take the P common, this will be 1 plus N R over 100, right? So this is just simple interest, and this is the total value at the end of N years, including the simple interest, right? So this is just a basic idea about the simple interest. So everything is clear till now? Okay. And please let me know if there's any sort of confusion. And I will repeat the point that simple interest is always calculated on the principal amount, on the initial amount. That's why the interest is same for each year. For example, if a person has, and first tell me one thing, all of you know about the arithmetic progression? We will discuss this in the series concept, but for timing, everyone of you know about the arithmetic progression, usually called as AP. There is a common difference in each, this is a series in which there is a common difference in each of two consecutive terms, right? So let's suppose this is X, and next will be 2X, this will be third X. So if you subtract these, there is a common difference, which is X, right? Okay, so why I just told about this, the thing is, in simple interest concept, first of all, let's suppose a person invested 1,000, and there is a simple interest of, let's suppose 5%, right? And after 1 year, what will be the final value, including the interest? That will be 1,000 plus 5% of 1,000. What is that value? That is 1050, right? I just included in this the simple interest, which I just consider 5%. Now in the second year, at the end of second year, what will be the final value now? Yes, anyone? Considering the rate of interest 5%, and for time being, I'm only including only considering the rate of interest per year, per annum, right? Okay, so what will be the total value?
1100 in second year.
Yes. You can also see that this is the value 1050 plus 5% of what value? 5% of 1050 or 1000?
5%
1000.
of 1,000.
Yeah. So this is the main difference between the simple interest and the compound interest. The interest is always based on the principal amount, not the total amount, which is at the end of the previous year, right? So 5% of 1000, this will be 1100, right? Okay. So if I ask you one thing, that if a person invested 1000 and after 2 years, he got a total return on investment, including his investment and the rate of interest he got, for example, 5,000. And if I ask you that, what will be the total value of his investment and the interest at the end of 6 years? Can anyone tell that? In 2 years, his 1,000 investment is just becoming 5,000. Oh, sorry, not 5 lakh, 5,000, right? So what will be his total investment will become at the end of 6 years?
13,000.
13,000. Okay, let's see. So this is actually the concept of simple interest, or you can say that arithmetic progression, that in 2 years, his amount, his investment is increased by how many value? $4,000.
4,000.
So next 2 years, again, the investment is increased by $4,000. So it will become 9,000. And again, after 2 years, there is increase of 4,000 and it will become 13,000. So every one of you know why there is a constant increase? Because the interest is always based on the principal amount. So between any two consecutive period, maybe years, month, or whatever the period is, the increase is constant. Just like here, the increase is 50, 50, in order of 50. That's why if there is increase of 4,000 in 2 years, then in each of the next 2 years, there will again increase of 4,000. This is what the concept of arithmetic progression. And sometimes the question of the simple interest are tested this way. So everyone got the point?
Yes.
Okay. So this is, let's see the another aspect of the simple interest. Okay, so if I say that the next concept is regarding the, if I say that principal amount is increased by X times, this is one thing. And the next thing is the principal amount become X time. These are two totally different things, right? If I say that I invested 1,000 and after 3 years, the investment become 3 times. And if I say that I invested 1,000 and after 3 years, the investment increased by 3 times, both are different things. To understand it, let's see a basic scenario. For example, if I say that after the, if I say that, for example, after n years, our principal amount become twice of the, our total value at the end of n years become twice of the principal amount, right? And at first, I just consider A as the final amount, and just considering the first scenario, I just say that this value, let me add 1%. This value just become the twice of the principal amount, right? So just using the formula of the, let me just write the formula first. 1 plus R1 by 100. Okay, so even now we're familiar with this formula, right? I just added principal amount and the simple interest, and just take P common. So this is a formula for the final amount at the end of n years, right? So I'm just first considering the case if the final amount is twice of the principal amount, right? So what will this formula become? This will be 2p is equal to p into 1 plus r1 over 100. So this will become 2 is equal to 1 plus r1 by 100, and r1 over 100 is equal to 1, and r1 is equal to 100. For time being, just consider this. And if I see the next thing, that our final amount just become the thrice of the principal amount. So this will be 3p is equal to p into 1 plus r1 over 100. So the final value after just solving this, that will be r1 is equal to 200. And if I consider the final value as thrice of the principal amount, so at the end of by solving this,
4 times
4 times,
principal.
okay. Now the 4 times, this will be 4p is equal to p into 1 plus r1 by 100. So this will become 3 is equal to r1 by 100, and r1 is equal to 300, right? Now there is a sort of pattern in this. To understand that pattern, let's consider that our final amount is increased by x time. So if I consider this, a is become x time of the principal amount, in that scenario we have xp is equal to p into 1 plus r1 by 100. This will cancel out, and x minus 1 is equal to r1 by 100. So r1 is equal to x minus 1 into 100. Where, okay, so based on this formula, if I say that our final value is twice of the principal amount, right? So just substitute x with 2, and this will become 100. And if I say that our final value is just the thrice of the principal amount, so this will become 200. And if I say fourth time, this will become 300. So this is just a generic form of just considering these. So I even got this, what I did here.
What is A here? The final amount?
A is just, I call final amount include, which is the addition of the principal amount and the simple interest,
Okay.
right? If I just again tell you about this, that if our final amount is the x times of the principal amount, I am saying final amount is x times of the principal amount. Let's call this P, right? So in that scenario, R1 is equal to R is rate of interest and is total number of years. X is the value for which the final amount, that is the value that final amount is that much times of the principal amount. So whatever the value of X is, you can simply incorporate in this formula, and you are asked to find whether R or whether N, right? So you can find any of these two just by knowing the X in this formula. And I told you already, this is one thing, that final amount becomes X time. If I say that the final amount is increased by X time, so what will be the difference in this old formula? Just to understand it in this, for example, if I said that I invested $100 in a company, or I just deposited $100 in a saving account, and based on that, after 1 year, my principal is just increased by 1 time. So after 1 year, what will be the final value? Principal amount plus 1 time increase, right? 1 into 100. So that will be 200. If I say that after 1 year, my values increase by 2 times. So in that scenario, this will be 100 plus 2 into 100, which is 300, right? So just see that this is by increase of 1 time. This is by increase of 2 times. By increasing 1 time, our value just become the twice of actual investment. And after adding 2 times, our value is just thrice of the actual investment, right? So if I just make this for such formula, there's only one difference, that Rn will be equal to x into 100, not x minus 1 into 100. So you got this formula? This is when our final value is x times of the principal amount. And this is when our final value is x times greater than the principal amount. Just remember these two formula. Though you can solve the question pertaining to this without these, but remembering these two formula will help you to solve such question very quickly, right? So just remember, I will just write these a bit separately. When A is x times of P, so this will be R1 is equal to x minus 1 into 100. And when A is x time more than P, in this case, R1 is equal to x into 100. So every one of you just understand the difference between these two. What I meant by x times of P and x times more than P. If yes, then I will move forward.
Yes.
Okay, so let's move to the compound interest now. This is just a basic intro about the simple interest. Okay, so next thing is,
Can we first do the practice questions of simple interest?
okay, so let's solve the questions for the simple interest. Okay, try this question. First, let's solve the question from simple interest, then we'll move to the compound interest. You have just 1 minute to solve this question. Okay, let's solve this question. This is a very basic question. Ron invested a certain sum of money at 8% per annum, right? So rate of interest is 8% per annum per year. At a simple interest, okay, for a simple interest and for n years, right? So let's n be n years. The next thing is, at the end of n years, Ron gets 4 times of his original investment, right? 4 times of his original investment. What is the value of n? First, let's try to solve this by a conventional way. Then we will use that formula. Okay, so let's consider that this person invests around $100, and after n years, his investment becomes 4 times. So what will be that value? And if I call that A, that will be 4 times of 100, which is 400. So based on these two, can I find the simple interest? Because A is equal to P plus simple interest. So simple interest is equal to A minus P, which is 400 minus 100. Is equal to 300, right? So simple interest is 300. Now just use a simple interest formula. A simple interest is equal to principal amount into number of years into rate of interest over 100, right? So simple interest is 300. Principal amount is 100. Number of years is what we are asked to find. And R is 8 divided by 100, right? And this will cancel out, and n is equal to 300 divided by 8 years, which is 37.5 years. This is first way to solve this question. Anyone got this way? Simple, I assume a value for my investment, and based on that, I just find the final value, and based on that, I just find a simple interest, and using simple interest formula, I just found the number of years. Okay, so now just use the formula. And I told you formula that whenever final value become X times of the initial investment, so we use R1 is equal to X minus 1 into 100. Here R is equal to 8%, and N is what we are asked to find, and X is 4. So just simply use it. This is 8 into N is equal to 4 minus 1 into 100, and N is equal to 300 divided by 8, which is 37.5 years. So this is just the formula which we discussed. You can solve by both ways, but just keep one thing in mind. The question is saying got big 4 times. If a question says 4 times more, right, so the scenario will be totally different. So just be cautious about the wording. And GRE in exam, usually the trick is about the wording, not about the concept. So, okay. Okay, so let's solve this question now. And be quick, take at max 1 minute to solve this question. One way is that from which we did earlier, just using that formula, first find the rate of interest, and based on that, just use the formula of the simple interest and find the total value. But try to use the concept of arithmetic progression here. That the question is saying that Alan invested 100 at a simple annual interest, and the investment become 3 times in 12.5 years. So at start, this is 100, and at the end of 12.5 years, this actually becomes 3 times, which is 3 of 100, which is 300. So the increase of $200 in 12.5 years. Remember, this is simple interest, and simple interest is same between any consecutive time periods, whether you are considering month, days, year, quarter of the year, whatever you're considering, the interest will remain same between these two. And in 12.5 years, if there is an increase of 200, then in next 12.5 years, there is again increase of 200. So this in total is 12.5, 12.5, 25 years. So starting investment of 100 in 25 years will become how much? $500. Got the point? 100 till here 300 plus 200, which is 500. Simply use the concept of the arithmetic progression. Because difference between two consecutive time periods is same, right? So if 12.5 years, the increase of 200, so there also increase of 200 in next 12.5 years, which in total add up to 25 years. That's why I answered this question is 500. We can also solve this by the simple conventional methods, but that is not recommended unless you are doubtful about your process. So everyone got this?
Can you please explain it again?
Okay, I was saying that initial investment is of $100, and in 12.5 years, this value become 3 times, which is 3 into 100, which is 300. And there is how much increase? 300 minus 100, 200. So there is simple interest of 200 in between 12 in a period of 12.5 years. So for next 12.5 years, what will be the increase? That will be the same 200, because this is simple interest. That remains same between 2 periods, whatever you're considering. So again, in 12.5 years, the increase of $200. So in total, this is 12.5 plus 12.5, which is 25 years. So in 25 years, you started with 100, and the value add up to 100 plus 200 plus 200, which is 500. That's why after 25 years, the investment, as a result of investing, the total value rose up to $500. So you got this point now?
I have this doubt, like in the question it says, and the investment becomes three
Three times.
times. Like, yeah. So it's not this, it's not same as like that's not the actual amount, right? The total amount. It's different from that. It's three times of the simple interest, right? And not the total.
3 times. Whenever you say
Yeah.
three times, it's 3 times
It's
of
3x.
the principal amount.
Okay.
Because you started with $100 as a principal amount,
Mhm.
and you say that after such years, the value become this much time, then you have to consider what value. If it is not mentioned, then you have to consider principal amount, not the interest or any other value.
Okay.
This is a way you need to find the simple interest, right? So in 12.5 years, the total simple interest is $200. And for next 12.5, this is also same. And that's add up to $500.
Okay.
Okay. Yeah, try this now. This way of asking the simple interest is pretty much common. So try to solve this. Okay. So the person invested 12,000 in a bank for a month and earns a simple interest of 120 in first month, right? So it's interest for 1 month, not for 1 year. So what is the annual interest rate? You can solve this logically by various ways. If you can see that the simple interest for 1 month is 120, and a question is saying for annual interest, so what will be the simple interest for a year? That will be 12 times of this value, because this is for 1 month, and for 1 year this will 12 times, because of 12 months in a year. This will be what value? This will be $1440. So to find the annual interest rate, what we should do further? This is our total simple interest divided by total investment at the start in 200. So that will be 1440 divided by 12,000 in 200. And this came out to be 12%. You can think of this question this way. And you can also use the simple interest formula. As simple interest formula is principal amount into rate of interest into time divided by 100. The only difference is this is for 1 month. You need to convert this for year. And for that, this will become 1/12. That's the only difference. Just find the rate of interest from this, which came out to be 12%. Either solve this way or use simple interest formula. You will just land up for 12% interest. Okay. This is a similar question. You can solve this later. Yeah, try this question. Invested amount of $5,000. Okay, the total investment is 5,000 at the start of 2001. Okay, from one fund he was earning the interest of 5% per annum, and the next interest of 8% per annum. Just read it clearly. The question is saying invested an amount of 5,000 in 2 funds. If the question says 5,000 in each of 2 funds, then in that scenario, this is also 5,000, this is also 5,000. But the question is saying he is investing total 5,000 in both of these, right? So he's investing some portion of 5,000 with 5% interest and some portion with 8% interest. For time being, if I consider that he just invested X amount out of 5,000 with 5% of interest, and the remaining, what will be the remaining? That will be 5,000 minus X, and he invested the remaining amount with 8% interest. Okay. The next question is saying that total interest earned by him for both of these funds, the simple interest considering both of these came out to be 315. Okay, now let's see what is happening here. X is invested with the 5% of interest, and remaining portion out of 5,000, total is 5,000. That will be 5,000 minus X is invested at 8% of interest per annum. So whenever you whenever you see the interest question, be clear about that rate. Rate is about per annum, per day, per month, right? So this is per annum. Okay. And the result of the simple interest, addition of simple interest by both of these is 315. So what is a simple interest earned by first? Let's write this way: simple interest for 5% plus simple interest for 8% equal to 315, right? And what will be simple interest for 5%? What, first of all, tell what is the formula for simple interest? That is principal amount into rate of interest into time divided by 100. In our scenario, the time paid is 1 year, right? And we are given the rate of interest and we already know the principal amount. So the first value will be X, the investment for 5% into 5 divided by 100, and the year is 1. Okay, because starting from 2001 and at 2001. Okay, plus what is the investment for 8%? That is 5,000 minus X into 8% multiply by 1, the time period is equal to how much? 315. So this will be 5x over 100 plus 5,000 minus x into 8 over 100 is equal to 315. So just take 100 common and move to the right side. This will become 5x plus 5,000 minus x into 8 is equal to 31500, right? So if you proceed further, this is 5x plus 40,000 minus 8x is equal to 31500. This is 00. And if you proceed further, this will be 3x is equal to 8500 and x is equal to 8500 divided by 3, right? So the investment at 5% of per annum, this is 8500 divided by 3, and investment for 8% will be 5,000 minus x, and x is 8500 divided by 3, and that came out to be 6500 over 3. So it is very much clear that quantity is greater. There is very quick way to solve this. We will discuss that in the weighted averages concept when we discuss the shortcut way. Okay, so till now you got the point how we solve this question. Shall I move forward? The next questions are, there's one more question relevant to this. You can solve this later. And the rest questions are from compound interest. Shall we move to the compound interest now? And now we are moving towards the compound interest. First of all, let's see the difference. Simple interest is always based on the principal amount, but the compound interest is based on the principal amount and the investment interest that accumulates on it in every period. For example, let me write first. It is based on principal amount and the interest that accumulates on it in every period. We will discuss in detail what I actually write here. But for time being, just consider that simple interest is based on only the principal amount, but compound interest is based on the total amount of the end of, which is total amount of the preceding, of the earlier year at the end of earlier year. Okay, let's see. First of all, let's see the formula of this, that, and then we will move forward that how such formula is derived and how can we understand this formula. So compound interest, and if I call the total value as A, just like I call that A total value at the for the simple interest, that is principal amount into 1 plus R over 100 into N, right? This is a total amount at the end of N years. This is principal amount. This is rate of interest. Let me go total amount, principal amount. This is rate of interest per year. Because, okay, I will tell you later. This formula is for rate of return per year per annum, and this is total number of years. There is, if you see this, I just wrote rate of interest per year per annum, but there will be a bit difference if I change, if the question asks that the rate of interest is not per year, but per the quarter of year, per semi-year, per month, per days, then there will be a bit change in this formula. And before getting into that, let's understand that how this formula is made. For example, if I say that, let's consider the 3 years, first year, second year, and third year. And I assume that, let's suppose our principal amount is $100 and our rate of interest is 20% per annum per year, right? Okay, so now in first year, principal amount is what? $100. Our rate of interest on our interest value on this will be what? That interest is 20%. So our interest came out to be 20% of 100, which is 20. And our total value is 100 plus 20, which is 120. And remember one thing, if you are considering the rate of interest per annum, the value for the simple interest and compound interest will be same. And the only difference arises when you move further from 1 year in second year or after that. Okay, so now at the first year is just finished, and start of next year, our initial investment, our initial value will be 120. Now the question is, what will be the interest value? Interest is actually the 20% of what? Whether 120 or whether 100 of A, which is 120. That's the only difference, that in the simple interest, we take the rate of interest of the principal value. But in the compound interest, we take the interest percentage of the, we take the percentage rate of interest of the value, which is at the end of the last year, preceding year, which is 120. And 20% of 120 is 24. So this is principal for this now. And the final value at the end of second year is what value? That is 120 plus 24, which is $144. And now at start of third year, our initial value just become 144. Now what will be the interest value for this? That is 20% of 144, which is 28.8, and our final value will become 144 plus 28.8 equal to 172.8. So till now, every one of you got this, what I did here? If yes, then I will proceed further. I just assume that principal amount to be 100 and 20% rate of interest per annum. And at first year, this is the principal amount, this is the rate of interest, and our interest came out to be 20. So at the end of first year, our total value is 100 plus 20, which is 120. Now at the start of second year, our initial value is 120 and this value, and the interest is of 20%, and this is compound interest. That's why we consider 20% of this value at the start of that year, including the interest and the principal amount of last year. That came out to be 24, and total value for that and the end of that year is 144. And now this will be the starting value for next year, that is 144, and 20% of this is 28.8, and our final value just became to be 172.8. Till now everything is clear? Shall I move forward? I'm just trying to build formula from this. Okay. Now let's move backward from third year. At third year, our final value is 172.8, right? That is 144 plus 20% of 144. Is this right? Okay, so if I do this way, if I take the 144 common, this will 144 plus 1 by 1 plus 20%. Okay, let's hold to this now. Now what is 144? 144 is the value at the end of second year. And if I just open the 144, that is 120 plus 20% of 120. And this will be 120 plus 20% of 120 into 1 plus 120 or 20%. If I take 120 common, this will be 120 into 1 plus 20% into 1 plus 20%. Let's call this B for time being. Now, if you see the end of first year, this is 120, and 120 is 100 plus 20% of 100. This is, if I open this, this will become 100 plus 20% of 100 into 1 plus 20% into 1 plus 20%. And if I take 100 common, this will be 100 into 1 plus 20% into 1 plus 20% into 1 plus 20. And this will be 100 into 1 plus 20% whole cube, because all of these bases are same, the power will add up. So this will be 100 into 1 plus 20% whole power cube. Isn't this the formula of the compound interest? What is the formula for compound interest? That is A is equal to P into 1 plus R by 100 into N. And in this, the question above, we consider N as 3, R as 20%, and P as 100, right? So this is just the formula. This is just a sort of intuition-based, what can I say, generalization from the formula. And this is exactly the shape of formula. So I even got this, how I come up with this formula, by taking the values. Is there any confusion till now? Because if no one responds, how could I know that? Okay, so no one. Let's move forward.
So all clear.
Okay. One more thing, and that's the last thing. That thing is that earlier I told you that this formula, this generic formula, is when we are considering the rate of interest per annum, right? So this formula is applicable when we are considering when R is percentage per annum, rate of interest per annum. But for example, if a question, and usually for the compound interest, the statement is like that, and a value is compounded for 5%, compounded for 10%. So whenever you see the word compounded, that's mean there is a compound interest. Okay, so if the question say that instead of compounding rate of interest per year, the question said the compounding per month, compounding per day, compounding per quarter of year, or compounding per what can I say, semi-year, right? So for that scenario, there is a sort of modification in this formula. What will be that formula? That formula will be A is equal to P into 1 plus R over C into 100 whole power N into C. Rest is same. The only difference is with this C, what this C will be. And if you are considering per year, right, C will be 1. So that is exactly the basic formula. This is for per year, compounding per year. And compounding semi-year, that will be per semi-year. For that, C will be 2. And compounding quarter of year, for that, per quarter of year, C will be 4. And compounding per month, for that, C will be 12. And compounding per day, that will be 365 days. Right? So just remember this formula for the compound interest. And for C, if you are compounded, given that the investment, but you're investing compounded per year, so that in that case, C is equal to 1. And compounded semi-year, for that case, C is equal to 2, because we are dividing whole year in 2 parts, 6 months and 6 months. That's why C is equal to 2. And for quarter, C is equal to 4. We are dividing in 3 months each. And for months, there are 12 months. That's why C is equal to 12. And last days and year, for year, normal year, there are 365 days. That's why we consider 365, unless mention that the leap year, whatever the conditions are, right? So just keep this formula in mind and read really whether compounded per month, per day, per year, per semi-year, per quarter year. Okay. And remember one thing, as this is a power, right? So increasing the power, the values actually increase. So just remember one thing, when you are compounding per day, the final value is always greater than compounding per month. This is greater than compounding per quarter of year. This is greater than compounding per semi-year. And this is greater than compounding per year. Just keep this in mind. That as the compounding value is getting greater, your actual value is actually increasing, right? So per day is greater than for per month, which is greater than per quarter year, which is greater than per semi-year, and which is at last greater than per year. Okay, so just solve this question and try to solve this a bit quickly. And okay. Simple question. Given interested $8,000 for 1 year at simple interest rate of 6%. Okay, $8,000 at 6% annual rate of interest, right? Annual interest rate. And this is simple interest. And 10,000, and both are for 1 year. And 10,000 annual rate of interest, 8%, compounded semi-annually, right? This is not compounded yearly. This is compounded semi-annually. So what is the total amount of interest? Okay, so let's see what the interest came out to be based off both of these. So first one is simple interest. Simple interest is simple P, principal amount, into rate of interest into time period over 100. And you're asked to find a simple interest. That is, what is principal amount? 8,000. What is rate of interest? 6%. And N is 1 year. Divided by 100. So this came out to be 480, right? So simple interest for investment of 8,000 for 1 year and at 6% simple annual rate of interest is 480. And now see the other case. Now the investment is 10,000 and rate is 8% compounded semi-annually. If I use that formula, that is total amount is equal to P into 1 plus R over 100 into C over N into C. And here we are given that N is equal to 1 and this is compounded semi-annually. That's why C is equal to 2, R is equal to 8 and P is equal to 10,000. So total value at the end of 1 year based on the compound interest of 8%, this 10,000 into 1 plus R is 8 divided by 100 into 2 into 2 because N is 1. And after solving this value is around 10816, right? Now the thing is, this is a total value. And for finding the interest of compound interest, you need to subtract the initial value from this. And what is the initial value? 10,000. And this came out to be 816, right? So the interest from the first one is 480 and interest from the second one is 816. So just add both of these. This is 6, this is 9, and this is 12. So 01296, which is this E. So everyone got this? This is a very basic question. The only trick was that this is compounded semi-annually. Okay. Now another quick question. What is the answer to this? The question is saying the investment received 20% annual interest compounded semi-annually, right? So C is equal to 2 for 2 years and will also be equal to 2. If the final value is 29,200, and if we consider final value as A, that is 29,200, the question is, what was the initial value? And just using the formula for the compound interest, that is A is equal to P into 1 plus R over C into 100 power C into N, and our final value is 2920 is equal to P, which we asked to find, into 1 plus R. R is 20% divided by 100 into 2 whole power 2 into 2, and this will be 29200 is equal to P into 1.1 whole power 4, and P will be equal to 29200 divided by 1.1 whole power 4. So what's the answer to this now? What's the answer to this now?
D
This-
is the answer.
Yes, this is a bit close to 20,000, 19,900 something. So the closest answer, this is D, not ERC. Right? Okay. This is almost the same. The only difference is that now the investment is compounded quarterly. So C will become 4. The rest simply use the formula and you can quickly just come up with a value. Just leave this question. Yeah, try this question now. John deposited 10,000.
Answer is D, right?
Answer
I
is
couldn't hear you. D?
yes, answer is D.
Okay.
John deposited 10,000 to open a new saving account that earns 4% annual interest. Okay, compounded quarterly. So first of all, our principal amount is 10,000 and the rate of interest is 4% compounded quarterly. If there were no other transaction in the account, what was the amount of money in John account 6 months after the account was opened? Okay, so let's try to solve this without using formula. Okay, principal amount of $10,000 and rate of interest of 4% compounding and quarterly. And if there no other transaction in the account, what was the amount of money in John account 6 months after the account was opened? Okay, so if the rate of interest is 4% per annum, so the question is saying compounded quarterly. Can we say that this is 1% per quarter? 1% for 3 months, because C is 4, right? And if we divide 4 by 4, the result is 1. And that's why we can say that this is 4% per annum or 1% per quarter, right? So per 3 months, for each 3 months, the rate of interest is 1%. And the question is saying for 6 months, right? And first consider first 3 months. Let's suppose 1 to 3 months, right? First 3 months, the rate of interest is 1% and principal amount is 10,000. So what is the final total amount based on this? That will be P into 1 plus R, and not doing this, not use the formula for this. There it is. So yeah, there it is. Okay, so what will be the value after 1% interest? The final value will be 1.01, 10%, 1% addition into 10,000. What is that value? That is 10100. I'm just finding the total value based on 1% interest, right? So this is 10100. Now for next 3 months, 4, 5, and 6, right? Again, interest is 1%, and now the initial amount is 10100. So what is the final amount? This will be 10100 into 1.01, and that came out to be 10201. Simply D. So I even got this, what I did here. Okay. Yeah, the same concept which we did in the simple interest, but for compound interest, exactly we can't do that. And let's try to figure out how can we do such questions in compound interest. Try to solve. The question is saying that
Yeah, continue.
investment of 4,000, at R% per annum compounded annually per annum, okay, will become 16,000 8 years. Okay, and if 2,000 is invested at R% compounded annually, in how many years this investment will become 16,000? Okay, so at first scenario, we have investment of 4,000 and R is compounded annually, and final amount is 16,000, and total is N is 8 year. So using the formula for the compound interest, this is 16,000. It is equal to 4,000 into 1 plus R by 100 into, because this is the compounded annually, so C will be 1 into 8, right? So this will be 4 is equal to 1 plus R by 100 whole power 8. And if I take the 8th root on both sides, this will become 1 plus R over 100 will be equal to, if I write this 8th root, this will be 4, 8. This is 8. This you cancel out. 1 plus r over 100 is equal to 4 power 1 by 8, right? So for time being, just remember this thing. Okay, so better write this in the above. 1 plus r by 100 is equal to 4 power 1 by 8. Now, what else the question was saying? The question was saying that we have 2,000 invested and we want this to become 16,000. By again using the formula, finally 16,000 and investment is of 2,000, and that is 1 plus r by 100. And we are asked to find the number of years. So n is unknown here. So this will become 8. 8 is equal to 1 plus r over 100 whole power n. Again, taking the nth root, this will become 1 plus r over 100 is equal to 8 power 1 by n. Now, if you see closely, the left side of both are equal, so we can straightforward equate the right side. This will be 4 power 1 by 8 is equal to 8 power 1 by n. And what is 4 square? That is 2 power 2, 2 by 8. And what is 8? This is 2 power 3, so 2 power 3 by n. Now the bases are same, we can simply equate the power. This is 2 by 8 is equal to 3 by n, and 3 by n is equal to 1 by 4. This came out that n is equal to 12 years. We can't do this question as we did for the simple interest, because in simple interest, the interest is same for each year or whatever the period is. But for compound interest, it is not same. That's why they need to figure some other way instead of using this is not in the arithmetic progression. That's the actual thing. Okay, so any question for this? No question. Okay, so one last, yes. Okay, so one last question for this. And this is just to give you an idea. Just solve this question. This is the last question for today. Help us in approximation. The question is saying that Sarah invested this much amount in account that paid 6.2% annual interest compounded monthly. She left the money in the account collecting interest for 3 full years. And the question is saying, how much interest did she earn in the last month, right? First of all, this is the invested amount and the rate of interest 6.2% per annum, and that is compounded monthly. So what is the rate of interest per month? Just divide this by 12 for approximation. If I consider this as 6%, so per month will be 6 by 12 is equal to 0.5%. So rate of interest per month is 0.5%. And the question is saying that you're asked to find for 1 month. And this is approximation, right? So for when you're asked to find approximate value and your values are widely spread, right? Then in that scenario, you can consider this compound interest as a simple interest and just find the value. But the final, whatever you get the final result, that is a bit less from the actual result. For example, that if I solve this by the simple interest, considering 0.5% interest for 1 month, our value is something a bit closer to 200, right? Less than 200, right? I'm saying that, okay, let me solve. That we have 38700. What is 0.5% of 38700? That is around 1935 or something, 193 point something, right? A bit less than 200, right? Now this is simple interest. Though a compound interest is a bit greater than simple interest, but there is not that much difference. You can see the options. This is closer to 200, but next value is way greater than 200. That is a gap of around 500, right? So that's why the approximate value and the closest value is A. You don't need to solve using the formula and whatever you want to do. But in case of approximation, your options are widely spread and you're asked to find the compound interest, just consider that as a simple interest, and whatever your answer is, that is a bit less than from the actual compound interest, because compound interest for same period is greater than the simple interest.